Hello students, I Sumit Sharma going to discuss about the software development life cycle in software engineering. Before starting of development life cycle, we would like to discuss about what is software, what is software engineering, what is software crisis, what are the myths which we generally assume, and why we are going to read the software engineering. Then we are going to discuss about the software development life cycle, in what manners we can develop the software. So what you mean by the software? Actually, software is basically defined as a tool with the designated order of the instructions which perform the task to provide the desired result after obtaining the requirements of the users. It also consists of procedures, rules, related documents, associated basic data required to run the software. Software basically, we can conclude it can be a computer, it is a computer program which has some procedures, rules, some documents and some data we require. Then the combination of this all we conclude as a software. Procedures and rules include the step-by-step instructions to install, deploy, and use the software. Documents include the requirement document, design document, testing related documents. सॉफ्टवेयर के एग्जांपल्स हो गए आपके माइक्रोसॉफ्ट वर्ड इज ए सॉफ्टवेयर, एक्सेल इज आल्सो ए सॉफ्टवेयर व्हिच यू जनरली यूज इनटू योर डेली लाइफ. Microsoft PowerPoint is a software, Linux is a software, MySQL and Photoshop are the examples of the software. How the evolvement role of software increased in the life. If we consider it as a product, it transforms the information, produces, manages, acquires, modifies displays. As a vehicle for delivering a product like operating system, software tools, generally named as processes. Due to the failure and over budget rates are high and success. Cost of hardware and software is decreases by the time. Generally, manager and technical persons asked why are costs so high? Why cannot we find all the errors before release? Why do we have difficulty in measuring progress of software development? Now we to talk about the crisis. What do you mean by the crisis? It is basically software crisis is a term which we use in computer science for the difficulty of writing useful and efficient program in the required time. So software crisis was due to using same workforce, same methods, tools, even though increasing in the software demand, complexity of software and challenges will increase in the complexity of software. Many software problems arise because existing methods were insufficient in which we were developing that software. So as we understand, if we are following the same things regularly without modifications or without any changing, it will arise some problem for us. So we use same workforce, no technical improvement in the development, same methods, the tools which we are using while developing the software is same, the demand and the complexity on the challenges, then there arise some problems like budget problem, like efficiency problem, like quality problem, managing and delivering problem, etc. So these conditions we generally say as a software crisis. Fine. So crisis, the development was personalized. Early software development was personalized. Sophistication of application grew. Programs grew in size and complexity. The maintenance of software becomes difficult. projects were taking lot of time and longer than totally calculated. Fine. Costing was so high to develop as we have initially estimated it. It was being delivered to the customer only to fail. Error found by the customer were extremely difficult to trace and fix. Large size projects failed due to some reasons. Development teams are exceeding the budget. They are taking lot of time to develop the software. We are going to deliver the things very late, so customers are not ready to accept it. The quality up to not up to the mark, so we cannot stand by into the market. Not complete the user requirement. What user requires and what we developed is having the big difference. It was very difficult to maintain and was not easy to handle or easy to use. These were the large size projects failed because of these reasons. Increasing demand, complexity increase हो रही है, challenges increases हो रहे हैं, हम same workforce को use करते हैं, same methods को use कर रहे हैं, same tools को use कर रहे हैं. That's why the issues are arising. Causes क्या हैं software crisis के? The cost of owning and maintaining software was expensive as developing the software. All the time, project was running overtime. Software was very insufficient. Quality of software was of low. It does not meet the requirement. Software, what we require and what we have delivered, the difference is there. The average software projects overshoots its schedule by half. Fine. And the software was never delivered because we did not complete the task within the time frame. Solution of software crisis क्या है? There is no single solution to the crisis. The possible solution of software crisis is engineering, because engineering is a systematic, disciplined and quantifiable approach. For preventing the crisis, there are some guidelines. We can reduce the software budget. Quality of software must be high. We need to take less amount of time to develop the software project. Experience and working team members onto the development of the project, and it must be delivered. We must deliver the things. Failure का example, as we had the Y2K problem, it is generally known as 2000 problem. Windows XP in October 25, 2001, the problem was came in at that time. So, what is software engineering? It basically includes with the two keywords named software as well as with engineering. We have understand software as well. So, software is what? Programs, documentations and operating procedures. This is known as the software. Basically, in direct set of definition, if we look after the definition of the software, we've been discussed it. Programs and documentations, procedures, how to set up, operate the software system. Program is basically the subset of a software. What it contains? Source code and object code. Documentation means descriptions, how to operate, how to use the software. Documentation manuals having the analysis specification, design, how we implement it and how we test it. Analysis and specification defined formal specification, context diagram and DFD. Design having the flowcharts, ER diagrams. Implementation having the source code listing and cross reference listing. While testing have the test data and the results. Operating manuals or the operating procedures having the two parts, user manuals and operational manuals. User manuals having the system overview, beginner's guide, tutorial and reference guide is there. While operational manuals having the installation guide, system administration guide. Now we to talk about the engineering. Engineering, as we understand, is the process of designing and building something which serves a particular purpose and find a cost-effective solution to the problem. Engineering is a science, skill and profession of acquiring and applying scientific, economic, social and practical knowledge in order to design and build structure, machines, device, system, materials and processes. Manufacturing is the production of goods for use or sale using labor and machine, tools, chemical and biological processing or formulation. So software engineering is basically the engineering discipline which is concerned with all the aspect of software production. It should adopt a systematic and organized approach to their work. It must use appropriate tools and techniques depending on to the problem which we are going to solve and the development constraints. Use the resource available. So the definition according to the IEEE, it specifies the application of systematic, disciplined and quantifiable approach to the development, operation and maintenance of software that is applicable, that is the application of engineering to the software. According to the Barry Baum, the practical application of scientific knowledge in the design and construction of computer programs and the associated documentation required to develop, operate and maintain them. The engineering use methods, procedures, tools and standards. Methods give the different steps that you have to take: project planning and estimation, requirement analysis, design algorithm development, coding, testing and then maintenance. The tools provide automated support to the methods, case tools, coding tools, testing tools. Procedures basically defines the sequence in which the methods are to be executed. So according to the software engineering which we are known today, it is a design, it's a method, it's a requirement analysis, combinations of these all techniques, engineering infrastructure, engineering process, evaluation and maintenance, quality analysis, configuration management, testing, constructions and all. So these all include in the software engineering. Now we to talk about the characteristic of the software. It does not wear out like hardware, as we can understand and see it into the diagram. This is the useful phase which we can use again and again. Software may be retired due to environmental change, new requirement or new expectation. We can change the requirement. Failure curve of software we can see. Result of side effects you have seen. Idealized. Software is not manufactured, it's developed. The life of the software is from concept exploration to the requirement of the software product. It is one-time development effort and continuous maintenance effort in order to keep it operational. However, making 1,000 copies is not an issue and it does not involve any cost. In case of hardware products, every product costs us due to raw material and other processing expenses. So we can say it is not manufactured in the classical sense. It's logical rather than physical. It's not touchable. We can see it. Reusability of the components. Some components can be reusable after deploying in the one project, we can use those projects, those components into the other project as well. It is flexible. Most software is custom built rather than being assembled from the existing components. Some general myths are there, software myths. Management myth. Management myth says we already have a book that is full of standards and procedures for building the software. Won't that provide my people with everything they need to know? The reality, the very well exists, but is it used? Are the practitioners aware of its existence? Is it complete? Is it adaptable? In many cases, the answer to all is no. The myth is that if we get behind schedule, we can add more programmers and catch up. The reality is that it is not a mechanistic process like manufacturing. Adding people to late software project makes it later. Spend time educating the newcomers, thereby reducing the amount of time spent on the productive development effort. People can add it, but only in a planned and well coordinated manner. You can add more people into it, but in a well coordinated manner. The myth, if I decide to outsource a software project to a third party, I can just relax and let that firm build it. The reality is that if an organization does not understand how to manage and control the software projects internally, it will invariably struggle when it outsources software projects. Some customer myths are also there. A general statement of objective is sufficient to begin writing programs. We can fill in the details later. A formal and detailed description of the information domain function, behavior, performance, interfaces, design, constraints, and validation criteria is essential. So these characteristics can be determined only after thorough communication between customer and developers. Some myths like project requirement continually change, but change can be easily accommodated because software is flexible. Yes, it is true that software requirements change, but the impact of change varies with all the time at which it is introduced. If serious attention is given to upfront definition, the early request for change can be accommodated easily. The customer can review requirements and recommend modifications with relatively little impact on the cost. When changes are requested during the software design, the cost impact grows rapidly. Resources have been committed and a design framework has been established. Fine. Changes can cause upheaval that require additional resources and major design or modification that is additional cost. Changes in the function, performance, interface or other characteristics during the implementation have a severe impact on cost. Change when requested after software is in production can be over an order of magnitude more expensive than the same change requested earlier. Practitioner's myth. Once we write the program and get it to work, our job is done. The reality is that someone once said that the sooner you begin writing code, the longer it will take to get it done. Industry data indicates that between 60 to 80% of all effort expended on the software will be expended after it is delivered to the customer for the first time. Until I get the myth is that until I get the program running, I have no way of assessing its quality. While the reality is that one of the most effective software quality assurance mechanisms can be applied from the inception of the project, the formal technical review. The myth is that the only deliverable work product for a successful project is the working program. Reality is that working program is only one part of a software configuration that includes many elements. Documentation provides a foundation for successful engineering and, more important, guidance for software support. Software engineering will make us create voluminous and unnecessary documentation and will invariably slows us down. It's not about creating documents, it's about creating quality. Better quality leads to reduced rework, and reduced rework results in the faster delivery times. Now we talk about the process, software process. It is basically the operations in producing something, series of action changes, functions that achieve an end or a result we obtain. While IEEE specifies the sequence of steps performed for a given purpose. Actually, software is basically, as we have understood, that it does the specific task for the user to accomplish the perfect specific task we develop or design the software. So, according to the IEEE, the process is that sequence of steps performed for the given purpose. According to the Pressman, software engineering is the glue that holds the technology layers together and enables rational and timely development of computer software. The process defines the framework for a set of key or process areas that must be established for effective delivery of software engineering technology. Key areas from the basis for management control of software projects and establish the context in which technical methods are applied, work product are produced, milestones are established, quality is ensured, and change is properly managed. Common process framework, we can see activities, in which activities we have the task, we have milestone and deliverables, and then software quality assurance points. Now we were talking about the process. Common process framework is established by defining a small number of framework activities that are applicable to all software projects regardless of their size or complexity. Several task sets, each a collection of engineering, work tasks, project milestones, products, quality assurance points. Enable the framework activities to be adapted to the characteristic of the software project and the requirement of the project team. Umbrella activities specify quality assurance, software configuration management, measurement, overlap the process model. Umbrella activities are independent of any framework activity and occur throughout the process. Now we do discuss about the difference between the software engineering and the traditional engineering. Software is intangible. It does not degrade with the time as hardware does. Failures are caused by design and implementation error, not by the degradation of the overtime. While in classical engineering disciplines, the engineer is equipped with tools and the mathematical maturity to specify the properties of the product separately from those of design. The typical software engineering relies much more on experience and judgment rather than mathematical formula. So some differences I have been quoted here. It deals with software that is logical in nature, no volume, no mass, no color, no order, means it is intangible. While other engineering like mechanical, electrical deal with the physical entities have the weight, color, mass, etc. and they are tangible. There are no fundamental laws in the software engineering which guide development, design and implementation of the software, while in other engineering there are fundamental laws in other engineering that guide the development process. Software does not wear out with time. It is conceptual in nature, so it is not affected by the factors like dust and rain. While other engineering wear out with time as a result of physical or electrical changes. Environmental factors like dust, rain don't affect on the software, while environmental factors like dust, rain have effect on software. So till now we have been discussed the various things in the software engineering: myth, crisis, what is software, what are the myths on the management perspective, on the customer perspective, on the development perspective, and we also discussed about the difference between traditional engineering and the other engineering. In the next lecture, we are going to discuss about the software development lifecycle models. So please look after my next video.